Welcome to the fourth video in the Snakemake101 tutorial series. In this video, we're going to be discussing the params keyword as well as introducing script and R into our Snakemake workflow. So to begin, let's discuss a little bit of the syntactic rules that Snakemake has when it comes to shell. Typically, when you're writing shell commands and you want to reference a variable, you can use the $ and the variable. However, you can also use the $ and curly braces and the variable. Since Snakemake reserves curly braces for its own variables, the way that you have to escape these variables is in the shell command is to double brace it. A good way of demonstrating that is to use a for loop inside one of these shell keywords, and that way you will see what I mean. So let us have, instead of output here, let's just copy this command that we have and place all of it actually and have it just be file. And now for the shell, let's write this as a block. What we're going to want to do is not bother with anything like that, and let's just make that for loop that we made earlier. For I in 1.7 do. We're going to tab in because we're not savages. Touch file dot I.txt done. Put that there. So we're going to save this, and I'm going to delete file 1 through 7. Save the Snakemake and run it. And immediately there's an error, because here we have this curly brace format and it's not going to work. And the reason it's not is because Snakemake reserves single braces for variables for itself. So if we wanted to use them in a bash context, we have to use double braces. And now Snakemake will read this as a normal shell command. This obviously looks less like we want it to, and when you're starting to use things like awk, where you have double braces a lot more commonly, you have to make those triple braces, and so it starts to look a little bit sloppy. What we could instead do is to just move something like this into its own script. So we can just create a file, and let's call it touch.sh, actually touch file.sh, and make this a script. So let's add a shebang /user bin env bash, and then we're just going to for I in 1.7 do touch file.I.txt done, and save that. And here we can just make it as if we're just running that script, no problem. Of course, we will want to make it executable, otherwise it won't work. And I'm going to save the Snakemake and delete these files. And if we run Snakemake one more time, there's nothing to be done, because again, we have created our converted files, so it doesn't need to do anything. Our target already exists. I'm going to run Snakemake again, and just like before, it did the stuff we needed to, made file.whatever, and then converted.whatever. So this is to illustrate that we can run scripts from the shell command, the shell keyword rather, and that if we're writing scripts, we don't have to double brace anything. This double bracing syntax is only for escaping curly braces when you're using the shell keyword within a Snakemake rule. However, the easiest way to have done this was the original way that we had it, to just do touch and output. and to have this be the way it originally was. File.thing.txt with quotes around it. Let's expand this idea now into creating custom scripts that have inputs. And so what we're going to do is create a new script, and we're going to call it copy.sh. Actually, we're going to call it convert.sh. And we're actually just going to take this and move it into its own script. So once again, we're going to add a shebang /user/bin env bash. And it's going to be very simple. cp1 into 2. If you haven't worked with bash scripting before, this $1 and $2 just implies that these are the positional arguments after the command. So as we run this file, let me clear this. As we run this file, converts.sh, some file is going to be argument 1, and something else is going to be $2. So it just assumes those values. So we're going to save that. And here, instead of doing cp, we can do convert.sh, input output, just like before. Going to save that, delete all of these intermediate files, and we're going to have to once again make it executable. And then now if we run Snakemake, it should do the stuff just like before. So writing your own custom script and moving the bash code out of a shell block is just fine. Positional arguments work a-okay. And this would be a way to circumvent double bracing to escape the Snakemake bracing syntax if you wanted to. And of course, if you had many, many, many lines of bash code or other language code that you wanted to do, this would be a more sensible way of doing it than inserting it into a supergiant block in your Snake file. Now let's expand this idea out into using R in our workflow. If you already have R installed on your computer, that's great. We're going to be installing it into this Conda environment so that we can move this Snakemake workflow across different systems without issue. But there is something I do want to mention, and that is that typically people use R interactively, often with RStudio, but you don't have that kind of luxury when you're using Snakemake. And so we're going to be creating our scripts that are run top to bottom, which may be terrifying for people who have only ever used R interactively, but it's going to be fairly simple, and we're going to be doing a simple example. So let's begin with that. For certain VS Code related issues, I had to install R outside of VS Code in just a terminal. However, if you were to install it, in which you should for this tutorial, it would be conda install r-essentials. And you would press enter and you would say yes at the prompt. And once it's installed, you can verify that you have a functional R installation by typing in capital R, and then you should begin to see familiar text from R, where of course you can do the basic R commands, like any normal R session. So let's clear our workspace and actually get started on writing a script. And let's create a table, some sort of random CSV that we can put into R and do some sort of data processing with. So for that, let's create a header for this fake table. Say it's age, size, year, and index, and we're going to make it comma delimited. Table.txt, and let's have it show up here. And then we're going to create a for loop just to populate it with some kind of rows. For I in 1 to, let's say 30, we're going to echo 1, 2, 3, 4, and append that to table.txt. Done. And so here you can see we have this comma delimited table that has 4 columns and 30 rows. So what we're going to do now is to create an R script that is going to read in this table, do some stuff, and write a plot to a file. So I'm going to create a new file. Let's call it plotthings.r. And the first thing we're going to do is that we want this R script to take arguments the exact same way that our convert.sh does. And to do that, we're going to use this args variable, and the command for it is command args parenthesis trailing only equals true. What this is going to do is create this variable called args that we can index in standard R vector indexing fashion, and it's going to take on the values of any subsequent arguments that we give our plot things. So plot things.r, and then file1, whatever, file2. We would be able to index args1 would be file1, args2 is file2, and so on. So that's the first thing we're going to do. Next, and this is just a personal habit of mine for when I write our scripts, set directory, get work directory. And now let's read in the data. And we want to read.table. And we're going to read in whatever it is that we put in as the first argument. So here we are establishing that we want args1 is going to be the input table. args2 is going to be the output table, because let's say we'll mess around with the table somehow. And then args3 is going to be the name of the PDF with the plots. Okay, so reading in the table, we want to say that the header is there, of course, and that the separator is a comma. Next, let's just add some sort of column to the table made by messing with the stuff that's already in the table. So data, let's call this column rand, and it's going to be the age column plus some random value, runif 30, because that is the length of our table, divided by year. And then let's write that to a file. So write.csv, data, file equals args2, which, as we've said here, args2 is going to be our output table. Row names equals false. And let's say we also wanted to plot this. Normally, if you were doing an interactive session in R, you would do plot data dot, whatever, rand. Let's give it some plotting attributes, so pch19, color equals blue. So normally in an interactive session, you would just do this. However, we're not running R interactively, so the best thing we can do is to export this to a plot. And we can do that several ways. I'm choosing to do it the PDF way, where we just specify that we're opening up a PDF file and it's going to be this file. So args3. And we're making this plot, and then to close it off, we're going to do dev.off, which closes the PDF file after we've put the plot into it. If you also wanted, you could do save.image, which will save your R workspace that you can pull up later and explore. But for now, this is what we're going to do. Now we can go back into our snake file and incorporate this. For starters, let's make our plot things executable. And just for the sake of posterity, let's create a rule that creates the table. We don't need it to have any inputs, we just need it to have an output. The output is, of course, going to be called table.txt. And we're going to create it with a very simple shell block in which we do the exact thing that we did before. Which is echoing age, size, year, and index, and appending that to output. and then creating a for loop for I in, and here we are using the double braces again because it won't work otherwise. Tabbing in because we are good-natured people. And done. Okay, so here we have rule create table. That's doing the exact same thing we did up here to create the table. And now we can create our plotting rule. So let's call it rule plot. The input is, of course, table.txt. And the output is going to be, let's call it table mod for modified. And now let's also introduce this log keyword. Log is a form of output that does not get incorporated into the rule matching that Snakemake does to determine whether rules need to be completed or not and which rules can do it. So in this case, we're going to say that our plot is not actually the output that we need, it's just something that is also created. And so for that, we're going to say table plot.pdf. And I'm going to make a shell block. Actually, we're going to do it as one line. Our script plot things.r. And like before, we're specifying our inputs and outputs as these input variables. And because we have over here saying that argument 3 is the name of the PDF with the plot, and we have that written here, we can also include log as a variable. And I'm going to save this. So if we were to run the Snakemake now, it won't do anything. Because even though we created all of these additional rules, our rule all, which specifies the stuff that we want at the very end, it doesn't actually include any of these outputs. So Snakemake effectively ignores these rules. Instead, here we can tab in, comma, and let's say that we want table.txt, or we just want table mod. If we were to say that we want table plot.pdf, Snakemake will error out because there is no rule that outputs it as the actual output keyword. Because once again, log is not incorporated into the rule matching. So here we go, we saved it. Let's run that rule graph again. You can see in this rule graph that it's a little different. There's these two concurrent paths. Here we create those files and convert them into something. And that is some of the stuff that we specify that we want in rule all. Here it is for comparison. And then table mod follows a different set of rules that requires plot and create table. And these rules themselves have no interaction, which is why there are no arrows between them. So let's just run Snakemake. And then we can see that there was a small error or warning that R gave us about call names, which is fine. And instead, we have our table mod, which is the table that we exported from R. We also have our table plot, which let me blow that up. And here is the scatter plot of the imaginary data that we had. And you can adopt this and adapt this in all sorts of different ways to do exactly what you need from R, even if that means exporting, say, the R workspace. The other thing that's worth mentioning is the params keyword. We haven't used it yet, but params are often optional and they really help a lot with code legibility, but it also improves the iterability of certain rules. So params is its own keyword, as I mentioned, and here you would put in whatever params you need. So I prefer to name mine, so let's say there's a threshold of some kind. And like most other things, they come in the form of strings, and it would be something like -m 0.01, comma, you can add another one, like scale, I'm just making these up. That could be -s, you know, whatever is appropriate for the program that you're using. Scale could be 100, and so on. And that way, when you're performing the shell commands or you're using these Python blocks, you can include params as a whole, just like that. Or you can specify the exact parameter that you're trying to put in. So you could do params.threshold with this dot indexing that we've introduced before. This becomes very useful if, for example, these numbers indicate something that's also happening in our workflow. For example, let's say that you want to do some form of k-clustering with R, and the number of in the middle of these files indicates the number of clusters that you're trying to do for k-means clustering. In that way, let's say we had a clustering parameter. We'll call it k-clust equals, and that way, let's say the flag is k, and we can put in thing. Now thing, with every job, changes from 1 to 2 to 3 to 4 to 5, and here the parameter is actually changing in a important and useful way for us. And so when we include params.kclust here, this will in fact change with every job run and it do something really meaningful for us.
So that's all I have for these Snakemake videos. There is a lot more to Snakemake that we could be covering, like introducing conda environments, distributed computing, config YAMLs, injecting raw Python code, and things like that. If there are topics that you'd like me to cover, you can put a comment below. Please like the video. That would give me some sort of indication if these were actually helpful. Or you can reach out to me on Twitter at pdimens. There's a lot more material that we can cover. I can cover some of it because I don't know all of it, and maybe I could learn some along the way. But I hope this video has been helpful to you. I know that it would have been super useful for me to have something like this when I was really struggling for about a month and a half to figure out Snakemake for my own work. And thank you for watching. Have a good day.